Hello. I would like to give a quick overview of climate change with a special focus on 2022 for my students, for any member of the community or anywhere who is interested in this global problem that we face. First off, I like greenhouse gases, as should you. Because when sunlight comes to our planet, if all of it was able to bounce back into space, this liquid water wouldn't be here. Our planet would be too cold. So if we were to say, just based on the distance from the sun, how warm might Earth and Venus be? Well, this would be the predicted temperature, and Earth at minus 18 degrees Celsius. It wouldn't even have liquid water on its surface. So life would not be possible if there was no that there were no greenhouse gases. Welcome, Shemai. I was going to go through climate change, and then if you had any questions, address them at the end, if that was of interest. Did you have any questions to start off with?
No.
Wonderful, wonderful. And so we rely on these greenhouse gases, which trap that energy from the sun. And so sunlight reaches us, but instead of bouncing out of space, it helps to keep us warm. So our planet is not that cold at temperature, and life on Earth is possible. So greenhouse gases are certainly not an enemy in that sense. Now, because we're talking about energy and the absorption of energy, molecules can absorb energy, but they can only absorb specific packets of energy. And this has to do with the structure of the atom and the orbitals that the electrons have and how much energy it would take in this specific atom to move one electron from one orbital to another. But that isn't relevant to us. What happens, what is relevant is that there's all of this radiation from the sun that comes to us, and it would leave our planet and go back into space as heat, which we refer to as infrared radiation. Heat is a form of radiation, infrared radiation, and it can have different wavelengths. So, you know, some heat waves have a wavelength of 2 microns, some 16. Okay, so the question then becomes, are there molecules in the atmosphere which could absorb any of this? And the answer is yes, there are, because once again, molecules, just by the basis of their structure, have the ability to absorb specific wavelengths of light. So we know that, you know, if we wear a color shirt, a red shirt, a green shirt, etc. See, this blue shirt is absorbing red light and green light, but it reflects blue light back to our eyes. That's why it looks blue, all right? Some molecules absorb ultraviolet, like DNA. That's why we don't want to have too much ultraviolet light hit our cells, because it can bind mutations. So different molecules can absorb different kinds of this electromagnetic energy. And as you can see here, heat is a form of this. You can see heat actually radiating from these individuals' bodies. And just like there are molecules which will absorb blue light or absorb ultraviolet radiation, there are molecules which will absorb heat. Water is one of them. So water vapor is in the atmosphere, and water vapor is once again then a greenhouse gas. Greenhouse gases aren't bad. They simply absorb some of this ultraviolet some of this infrared light that would otherwise go into space. And now that it's not in space, instead, it is kept around our planet, helping to keep our planet warmer than it otherwise would be. So that's great. And water absorbs heat, but only in specific wavelengths. I'm sorry if the internet is slow and catching up. So something that you'll see here is there are windows. All right, jump ahead. There are windows where, while water vapor will absorb some of this energy, it doesn't absorb all of it. So water is not absorbing this heat, and this is going into space. Water is not absorbing this heat, and this is going into space. So then it becomes the question, are there Are there molecules that are in the atmosphere which can absorb heat, especially in these windows? All right, because this would keep heat around our planet, which otherwise would go into space. And the answer is yes. Carbon dioxide is one of those, and there are others. So carbon dioxide not only absorbs heat, but it absorbs heat in some of these windows. Now, this is not something mysterious or theoretical. You can take carbon dioxide or any gas, pass energy through it, and ask, does carbon dioxide absorb green light? Does it absorb ultraviolet light? Does it absorb heat? Does all of the energy that I shoot through this container of carbon dioxide get to the other side, or is it absorbed? So this is easily measured. Carbon dioxide absorbs heat. Okay. Now, I have a bunch of videos on this because, unfortunately, I have to keep updating these. So let me just go to the 2022 version, but there, are other versions from 2021. As we fly over a city at night, one of the things I think that's obvious is look at all of the energy that is needed for those cars, those buildings, et cetera. And a very large percentage of it is coming from fossil fuels. Fossil fuels represent carbon that was buried. I'll get back to that in just a second. And as we burn coal, as we burn petroleum for those cars and that electricity that you just saw, as we burn natural gas, carbon dioxide then goes up into the air. And we can measure that. And as you can see, since the late 1950s, when carbon dioxide in the atmosphere was first measured, there is a steady increase of carbon dioxide year after year after year. Now, it does undergo kind of a fluctuation month by month, as you will see. Some of this has to do with, when the northern hemisphere, which has more trees than the southern hemisphere does. In autumn, leaves are dropped, and then in spring, carbon is taken up for new leaves. So, there'll be some monthly variation as you can see, but there is a steady increase. Now, when I was born, which was around 1966, there was, maybe a little over 300 parts per million carbon dioxide in the atmosphere. In 2014, it got to 400, and 2022 got to 420. So in other words, when I was born, I'm old, but I'm not that old. When I was born, the parts per million of carbon dioxide in the atmosphere were 320, and now it's over 420. That means that about a quarter of the carbon dioxide in the Earth's atmosphere is new since I've been born. That's an amazing change for a planet. A planet is big. So our planet has gained a quarter of its heat-trapping carbon dioxide in its atmosphere in my lifetime. That's a short period of time for such a big change. Now, I'd mentioned that there are monthly fluctuations. So if we were to look at 2018, notice it goes up and goes down over the course of a year, January, December, et cetera, and that's normal. All right, 2019 was a little higher every single month. Every single month in 2019 was higher than every single month in 2018. 2020, you'd think, oh, with COVID, all of us were indoors, all right, and so we weren't driving as much, we weren't going into work, they didn't have to light the office building. Surely we wouldn't have released as much carbon dioxide. And the answer is it did go down. Notice that the difference between the orange dots and the purple dots are bigger than the difference between the purple and the red. But even in COVID, in that extreme, hopefully once in a lifetime change to, our society, we didn't stop this increase. Here's 2021, once again increasing, 2022. All right, so notice that this is just this constant increase. And when I say 2022 is the record, that's really not that as impressive as it would sound, because as you'll notice, 2018 was a record until 2019. 2019 was a record until 2020. 2021, we humans, to light that city and to drive our cars, we keep putting ever more carbon dioxide into the atmosphere. And so our planet just keeps going up every year will probably be a record for carbon dioxide levels. So this is just a quick overview of my video playlist. So at my YouTube channel, Dr. Jan 41, DRJAHN 41, I have a bunch of videos. Some are sillier than others. I mean, there are songs. These people get more and more shocked and awed as this goes by. So there's more information here if you'd like. But I'd like to mention a couple other greenhouse gases after talking about carbon. So once again, carbon dioxide, which is in solid form here in the form of dry ice, gets sucked in by these plants during photosynthesis to make bio stuff, sugars and other carbohydrates, lipids, etc. Because if we were to look at like this sugar or other biomolecules, notice that they all have these black atoms of carbon. This is an amino acid in a protein. So biomolecules are carbon-based. And when animals eat the plants, all right, the animals then have sugars and proteins and nucleic acids and lipids, which are carbon-based. And so there's this cycle of carbon dioxide coming out of the air for plants to use into biomolecules. Animals eat the plants. Both the animals and the plants respire. All right, the animals and plants can both die. And then this carbon dioxide then gets returned to the atmosphere. So it's a cycle. All right, carbon comes from the air into living things and then goes back to the air. The sticking point is there were fossil organisms which were buried before their carbon could be returned to the air. So once upon a time, about 350 million years ago, the forests of North America had all this incredible amount of carbon, and a good deal of it got buried before it could decompose and return to the air, and it became coal. So coal, all right, is, somewhere I have coal, I swear. Coal is the black carbon, which was buried millions and millions of years ago. So is petroleum. Petroleum comes from marine life. And so when we burn coal, when we burn petroleum, we take carbon, which was underground for hundreds of millions of years, and we return it to the atmosphere. All right, so that is why carbon dioxide levels keep going up. Unfortunately, carbon dioxide is not the only greenhouse gas which is going up. So is methane, so is nitrous oxide, and others. Now, these are greenhouse gases. We can measure that because you can say, what wavelengths of heat does methane absorb? Oh, it absorbs those. What wavelengths of infrared energy does nitrous oxide absorb, or ozone, or anything? We can measure all of these. Now, someone might say, well, who cares about methane because we don't release as much of it as we do carbon dioxide? That is certainly true. However, methane is more powerful as a greenhouse gas. 1 kilogram of methane will absorb as much heat as 34 kilograms of carbon dioxide. It's 34 times more powerful. Nitrous oxide will absorb 298 times the amount of heat as 1 kilogram of carbon dioxide. And then there are molecules, I'll mention sulfur hexafluoride in just a second, where they are 32,000 times more powerful greenhouse gases than carbon dioxide. And then it's a problem that methane levels are going up. Not only is carbon dioxide hitting a record high every single year, look at all of these years with methane. So here we go counting year by year. Here's 2016, 2017. All right. So once again, 2022 was a record-breaking year. That's not surprising. Every year has been a record-breaking year, not just for carbon dioxide levels, but for methane, our human activity, especially things like producing natural gas, growing rice. These are producing methane into the air. Nitrous oxide, which, from fossil fuel combustion, from agriculture, this keeps going up. And so once again, 2022 was a record year for nitrous oxide, which once again is about 300 times more powerful than carbon dioxide. Sulfur hexafluoride, there is not much of it in the atmosphere, but it is 32,000 times more powerful as a greenhouse gas than carbon dioxide. And once again, 2022 was a record year for this. And so every year, our human activity is putting more and more heat trapping gases into the atmosphere. So if the atmosphere gets more and more heat trapping gases, then it stands to reason that our planet is getting hotter and hotter. And it is. All right, so I'm sorry, once again, I have lots of videos, but I try to do one every year. I'm going to talk about 2022 because with a semester starting, this is a good time to, to talk about this topic. However, it is a tiny bit inconvenient because the final say on the data from the past year probably will not be out for like another 2 weeks. So we have an estimation of where 2022 ranks in all of recent history as far as being the warmest year. But it's an approximation. It'll be more of a conclusion in 2 weeks when the last data comes out. So just so you're clear on that. This black line is the average temperature of planet Earth from the early days when it was measured in the late 1800s. And this black line represents the average of the 20th century. So from the year 1900 to the year 2000, 100 years. All right, so let's say that's normal. So from 1900 to 2000, let's say that the temperatures on our planet, that was normal. That is then the black bar. So you'll notice that compared to this 20th century average, for a long time, the yearly average temperature was a little lower than average. And then there came a point where, starting in the 1930s, that every now and then there would be a year that was a little hotter than average, then lower than average, hotter than average, lower than average. But since the late 1970s, every single year is hotter than that average of 1900 to the year 2000. So clearly here, our temperatures keep going up and up. All right, and so in 140 years of record keeping, all of the hottest years have occurred since 1998. All right, every now and then you'll get a string where it's the hottest year until the next year, which is then the hottest year, and then the next year is the hottest year. So 2020 was the second hottest year on record. 2019 was the third hottest. All of the 11 hottest years have occurred recently. So once again, if records go back to here, if warm years were randomly distributed, there might be one in the 1930s, not one in the 1940s, et cetera. But the 11 hottest years have all been in the past 12 years. All right, so clearly this is a trend. And it is thought that the 9 hottest years have occurred in the past 9 years. And it's thought that 2022 will rank 6th as the hottest year when all of the data comes in, but we'll see that. Now, even though it's 6th overall, different parts of the world could experience the heat of the year differently. So for example, in the year 2022, North America had its 2nd warmest summer on record. And so there is no question, temperatures are going up. I consider this in greater detail in other videos. I wanted to focus on 2022. So temperatures are going up, and 2022 certainly fits in with that. So if you wanted to look at what was the hottest year, if you were, say, around in 1970, this would have been your list of the hottest 9 years. All right, if you were around in 1980, this was your list of the hottest 9 years. If you were in 1990, oh, look, there's a whole lot of 1980s in there. If you were around in the year 2000, now all of a sudden there's a bunch of 1990s there, et cetera. If in 2010, we get these. And then once again, as of today, the last 9 years have been the 9 hottest years. All right, so the amount of heat trapping gas in the atmosphere because of human activity keeps going up. The temperature keeps going up. There is a steady trend of rising temperatures. What does this mean? Well, it means that ice is melting, and ice is melting all over the world. Now, obviously, in winter there's ice, but that's not the ice I'm referring to. There has been ice which on Earth, which has been around for thousands of years. Maybe even in Antarctica, there's some which is approaching more than a million. So these are in glaciers and in ice sheets, where, say, in the ice ages, water froze, and it hasn't unfrozen since maybe the glacial maximum, which was say 12,000 years ago, or in Antarctica later. But if we look at our glaciers today, like here in Washington State, is Mount Rainier. This is the largest continental glacier in the continental United States. It is melting, all right, and we can see glaciers throughout the world. Here's where the glacier extended in 1950, and it has receded by 1970, and then receded more, and then receded more. And so our glaciers all throughout the world are melting. So that ice is melting. Antarctica is melting. Every now and then there's a big chunk which it becomes obvious. So in the year 2022, there was a chunk which was about 1.5 size, the size of Orange County, New York, where I'm teaching right now. So that's a lot of ice, over 3,000 square kilometers. NOAA, our National Administration for Oceanic and Atmospheric Studies, measures ice all the time. You can check in now. So this data that I'm giving you, or these images, by all means, feel free to go to the source. You can log on to NOAA's website, and you could see today how big is the ice sheet in Antarctica, in the Arctic. How does that compare to this time last year? So by all means, feel free to do this yourself. But what we can see is just a steady decrease over time in these ice sheets. Now, you'd have to pick a specific month to compare them, because just like in our area, winter has more ice, summer has less ice, and so you'd have to compare September to September, or March to March. But if we were to look at 2022, the trend continues, where in general, the ice in the Arctic just continues to decrease. And we're talking about millions of square kilometers, areas which would cover much of the continental United States. And so this is a huge area of ice which is melting. All right, so what I was giving you there is month by month. You can see that 2022 had less average than what was previously the expected norm. And if you were to take March, this is the time when there is the most ice in the Arctic. Notice that there's, just a general trend downwards. This is what's known as the maximum. The maximum just keeps going down. Every year, the Arctic has less and less ice at its maximum. Also, if you look at the minimum, where there's the least amount of ice, here, notice that has been going down and down and down and down. And the year 2022 is 10th for the least amount of ice at the maximum in the past 43 years of study, and also then 10th in the ranking for the minimum of ice. So ice has been measured for 4 decades. All right. Notice that all of the years when there has been the least amount of ice are the recent years, not 40 years ago in the 1980s or in the 1990s. So the ice is becoming less and less. And in 2020, we saw a continuation of that. The ice is not only is this happening in the Arctic and Antarctica, but also in Greenland. where the recent trend has been that every single year, 269 gigatons of ice is lost that isn't regained. So a net loss, and a gigaton equals 1 billion metric tons, more than 2 trillion pounds. So Greenland is losing ice, the Arctic is losing ice, etc. So what does this mean? Well, it means that the sea levels are going to rise. All right, now that's a problem for a lot of things. For example, I'll mention coral later, but so much of humanity lives close to a coastline. All right, so there are islands where people have begun to leave, realizing that it will soon no longer be habitable. But we have so many cities which are near the a coast that if sea level rises, then parts of the cities will flood. Already, Miami is drawing street maps for, in 10 years, this area will no longer be inhabited because of the rising sea levels. Even if we're not talking about simple flooding, this is an issue with other things like water, because as the sea level rises, it then contaminates the freshwater aquifers. So for example, Miami, once again, Miami, even if there are parts of the city which aren't flooded, nevertheless, fresh water is getting harder to come by as salt water begins to intrude on the aquifer. So rising sea level would certainly be a problem for those living near the coast, as so many people do. So, much of Bangladesh, much of Louisiana is below sea level. But even if we're not living exactly on the coast, this is a problem because extreme weather then is on the rise. Extreme weather can be hurricanes, severe winter storms, droughts, and wildfires, etc. And so I have a number of videos which I try to update, but let me go to the most recent one. As we talk about weather, I mean, there are so many ways we could address weather. One of the things that NOAA keeps track of is billion-dollar disasters, and they adjust it so that we're comparing oranges to oranges because obviously the value of $1 and the value of the billion years changes. So once we adjust for the value of the dollar. If you were to look at billion-dollar natural weather disasters, 2022 has seen a number of them. Now, once again, this is a quarterly report where these are ranked. So the last report was in November. Another one is out soon. I apologize that I needed to make this video before that final 2022 report could be out. But there were 15 natural disasters involving weather, which cost more than $1 billion. Now, 2022 had the most ever at 22 natural disasters, which were over $1 billion. 2021 had 20, that's the second in ranking, and we are currently at 15. All right, so there is a trend. If you ask natural disasters which cost more than $1 billion, if you look at the 80s to 90s to 2000 to 2010s to 2020 and 2021, clearly there is an upward trend on natural disasters costing more than $1 billion. And once again, this is NOAA adjusts this to make the dollars comparable. And clearly 2022, as of November, was at 15. Clearly that's, above the averages most years. If you say, what do these cost? So, yes, they cost more than $1 billion, but what exactly do they cost? Well, more and more. So not only are there more that are costing more than $1 billion, but each one is costing more and more. How many people lose their lives in these billion-dollar disasters? Well, this can change, obviously, from year to year in the nature of the disaster. But once again, there seems to be an upward trend in that. So climate change is causing real problems and real deaths. Now, it actually causes far more deaths than just those that die in the most severe storms, and I'll get to that a little later. But 22 is certainly continuing this trend of worsening weather. So I have more videos. 2020 was the most active hurricane season on record. And obviously, these storms, they cause loss of life and problems in the immediate time. But then also years later, it takes time to repair these. So I visited Puerto Rico a year after Hurricane Maria, and there were so many areas that still had not been rebuilt as were to fly in that you would still see all of these blue tarps for people who were using blue canvas to keep out the rain because their roof had not been repaired since the hurricane. And so later I'll talk about the cost of climate change to all of us. Certainly, there is the immediate loss of life in a flood or in a fire, etc. But a year after the hurricane, the official death toll was raised from 64 to almost 3,000 in Puerto Rico. Because obviously, if people are losing power and living without power, now there are people who can't get to the hospital. There's more heart attacks. There's people who can't receive medical care. And so climate change has more profound effects. And I'll get back to that in just a little bit. Once again, some people are now more preoccupied by flood, and not to be personal about this, but not that this is a big deal, but certainly in recent years, I've had my basement flood a couple of times, which never had happened, and that's a bit of an expense. And I'm sure a lot of people share that. Where in this storm, in this flood, I lost my crop, I lost my basement flooded, etc. In the Western United States, the problem is that it continues to get drier, and now there are more and more wildfires. And so, once again, this is a trend which is just continuing. So we keep statistics on what is average rain, what is mild drought, what is severe drought, what is extreme drought, what is exceptional drought. And if you were to go out west, you would see there's so many areas that are not just in drought, not just in severe drought, but in extreme and exceptional drought. All right. And so if you visit these areas, they just have, month by month. And once again, these are monthly reports. And if you'd like to keep tabs on this, by all means, you can. So just listing here the severe drought, the extreme drought, and the exceptional drought. And you can see what a big area and how many millions of people live in these areas which are undergoing exceptional drought. And so in July of 2022, about a third of the West was either in the worst exceptional or extreme droughts. At the end of 2022, just a few weeks ago, more than half of the 48 continental US was experiencing some level of drought. Now, this has so many effects. Obviously, wildfires are an issue. Wildfires in 2022 were not quite as bad as they have been in the past couple of years, but they were still far worse than normal. And so, if you travel to the west, there are certainly signs here. So this is in New Mexico. Just a warning to everyone to be careful and avoiding fires. If you were to drive, you see all of the burn scars from fires. Now, as we drive, some of these are this year, some of them are previous years. All right, but certainly wildfire is taking more and more of the West every year. Now, part of the problem is I realize that a lot of the people who will be most affected by this are a lot younger than I am. I'm old, so when I hear these reports, I'm struck by how much things have changed. The problem is for a lot of young people, the West has experienced exceptional drought their entire lives. And so when in the summertime, the West is in a drought, you say, oh yeah, that always happens. Lake Mead's level is dropping even further. Oh yeah, that's always been happening. Because, and that's a problem because I think this can blind us to how severe this trend is. Just for a lot of people, they haven't known anything else. Now, wildfires 2022 is thought to rank about 11th in the number of acres burned. But some states experience it worse than others, like New Mexico was especially hard hit this this year. From 1995 to 2015, these 20 years, this was the average number of acres burned, but you can see it's more than 3 times that in 2022. So for New Mexico, this wildfire season was 3 times worse than normal. Overall in the West, the number of acres burned was more than double what it was in the 1990s. All right, so certainly wildfires continue to impact us, and they affect so many people. Not only those who are directly impacted by loss of homes, etc., but then also just if you're breathing the air, and this is triggering asthma, etc. There was even a day here in the Northeast United States where there was a haze in the air that was from the Western wildfires. All right, so air quality in the New York State was less because of these wildfires, 1,000 miles away. Right, and so here was a wildfire which struck these unique trees known as Joshua trees, typical to the West. So I have data on different years. All right, but let me just kind of hit a bunch of other ones as I start to wind down. So it's getting hotter. All right. One of the things that scares me certainly is if you look at Lake Mead is the largest reservoir in our country. It is where the Hoover Dam is located. The Hoover Dam is creating so much hydroelectric power so that we have less of a reliance on fossil fuels. I'm sorry, I have a few more Lake Mead things. All right, yeah, so here's one. So here's the Hoover Dam. So the Hoover Dam, Lake Mead, really important. This is also where Las Vegas gets 90% of its water. So, this is an amazing structure, this dam, great for hydroelectric power, great for, Las Vegas. But if you look at where this white level was, this is where the water was in the year 2000. So in the year 2000, since then, water levels have dropped, more than 140 feet. Now, that's not accurate because this is the picture I took in March of this year. It's now gone down 25 feet more. This is terrifying. It's not only terrifying that the water level isn't just dropping, it's dropping faster. All right, if we see a drop, kind of like what the last 20 years has done, then this becomes what's called a dead pool. There's no more electricity being generated here. And with water not going over the dam, Las Vegas isn't getting its water from here. Once again, this is where 90% of the water comes from. And so if you were to just map, like, where were the water levels? They were here. All right, in the year 2000, and since then they've just steadily declined. And every time you make a graph, it becomes outdated. Once again, this was the 2022 in March. It is now 20 some feet below that. And so if you live out west, all right, then this is terrifying. Where are you going to get water, for crops, drinking water for the drinking water for cities? Where are you going to get water for cattle and for horses, etc.? So once again, I was amazed by how much water had been lost from Lake Mead in March. At the end of 22, it's so much lower than this. All right, and so climate change is just getting worse and worse every year at a slow enough pace that if you chose not to pay attention, perhaps then you could, not notice. But if you were to just, Lake Mead is obviously an obvious one. If you were to go to Lake Mead, there are these boats which were sunk at the bottom, which are now being exposed. Or there are these boat ramps, which now are just, unoccupied because there's no boats that can leave here. So this, I spoke to someone who said when they were a kid, and this person was in their 20s, this was really popular. You would put in a boat here and everyone would go out into the rest of Lake Mead here. But now this channel is so shallow, I mean, no boats can use this. So in essence, this area is no longer used for recreation, where apparently when this person was growing up, they said, this was quite, the spot. And so this is certainly a problem, but out west, the lack of water and the drought, which is affecting the risk of wildfires, et cetera. There are so many other possible things. Let me just hit a few more quickly. As the temperature changes, that's going to change disease-causing organisms, all right? And like mosquitoes. So there are mosquitoes that cause diseases like malaria that we typically don't see in certain parts of the world because it's too cold. But as the climate warms, that changes. There are a lot of habitats which are becoming uninhabitable. A lot of the Western United States is drier and drier and drier, which is a problem for life. Obviously, polar bears are kind of one of the poster organisms for what happens when there's less and less ice in the Arctic. This is affecting insects because the cold of the winter very often kills a lot of them. So there are fewer insect pests come the spring because of the cold winters when a lot of them die. But out west and even here in the Northeast, insects aren't being affected in the same way. And so a lot of these forests out west, you look at all the dead trees, that's because there are these beetles, the mountain pine beetle, which are not being killed to the same degree that they once were by the harsh winters. And so now they're killing more trees, which is providing more dead wood, which is now making the fire risk even worse. Here in the Northeast, I personally worry about the ticks, which cause Lyme disease. Lyme disease is already a grave problem in our area. And if there are more and more ticks because of the milder winters, then that's more disease which humans face. I'll get back to human disease in a second. The oceans are certainly going to be affected because not only are they getting warmer, but they're becoming more acidic. Both of those things are really dangerous to coral reefs. And so coral reefs are the richest areas of life in the ocean, and so important for humans, whether it be for fish or for tourism and scuba diving, etc. But the climate change is causing the bleaching of these coral reefs, where more and more corals are dying, which is threatening the Earth in so many ways. A couple of other things. Nuclear power plants need to cool their reactors in order to generate electricity. Well, there have been cases where nuclear reactors have to close because the water's too hot. You can't cool the reactor core with water which is at such and such a temperature. So there's all of these dangers. Now, I would like to wrap up in just a second. Certainly, this is affecting life around the world. Climate change is one of the things driving the current loss of life. We think we're living in one of the worst periods of mass extinction in the history of Earth. So there's certainly all of these effects on wildlife. But I'd like to end with a lot of people don't grasp the severity of climate change. Its worst effects will be faced by young people as they get older, as the droughts get worse and worse, as the extreme weather gets worse and worse, as sea level rises. And by the time it gets to the point where it's so bad that people must take notice, well, by then it might be too late. All right, so it's really, if anything is going to be done, it's by those of us who are alive now. But a lot of us might not pay it too much mind, because we ask how many people does climate change really affect in a year? Well, obviously, if the West is becoming drier and drier, there are just millions of people who are now having trouble with access to water and at greater fire risk. There are more people who die in severe storms. But then there are the things you don't think of. Because if there was a heat wave, one of the things which typically happens is emergency room visits spike because more and more people are having heart attacks during the heat wave. More and more people are having asthma attacks in the heat wave. Now, climate change is in part to blame, but climate change will then worsen the effects, say, of air pollution. So air pollution, the hotter it gets, the more ozone that there would be, which would then, trigger some of these heart attacks, et cetera. And so some studies have then asked, like, how many people say die of, I'm sorry, wrong one. How many people die of air pollution each year? It's millions of people. Now, in the United States, we've worked hard to get really good legislation to protect us from bad air, so Clean Air Acts and the rest. So most of these deaths are not in the United States, but nevertheless, air pollution kills millions of people per year, and climate change and heat waves will make it worse. And so it's not just a future threat that climate change represents. This is, causing increased levels of heart attacks, asthma attacks, emergency room visits, increased loss of property, increased, a change in property due to more flooding or more drought. So this is already a grave problem. And future, topics and lectures and other videos I've made can look at how this is affecting wildlife and the like. So this is one of the biggest threats to the future of our world and the world that young people are growing up in. And 2022 has just continued the trend. The heat trapping gases continue to rise. The temperature is way above average. The number of droughts, the Arctic ice, these are all showing the 2022 is in one of the more extreme years. So this was similar to videos in my playlist, but I just wanted to give an update for this